Okay, so let's say we have a particle of mass m and we put it into a cone and we want to describe the motion of this object in this cone. And so we have a vertical axis here, and the particle, it's at some location, so it'll have some value some height, z. It's here. It'll have some distance from there that's changing, r, depending on the height. There's an angle here. Let's call it phi. We have some, so the location of the particle is there. Then we have some, here we have some angle theta. And so we have some r, theta, z coordinates to describe this particle's location. But the constraint is such that here we see we have a right triangle, opposite is r, adjacent side is z. And so we have the constraint that z is related to r by the cotangent of phi. So the cotangent of phi is z over r, right? It's adjacent over hypotenuse. So let's find the Lagrangian. We need the vector position. We need to find the velocity and construct the kinetic energy. So its location has an r value. We'll have an r hat. It has a z value, a height, in it's a k direction. And so when we take the derivative in time of that, we get r dot, r hat, but this also changes with time. And so we get an r that changes at a rate theta dot. So we have theta dot, theta hat, plus z dot, k hat. And so we can now square this. So r dot squared, of course, we'll get rid of the vector. So this will become r dot squared plus r squared theta dot squared plus z dot squared, which can be written as r dot squared plus r squared theta dot squared plus r dot squared cotangent squared of phi. And so our Lagrangian can be written as m over 2 times r dot squared times 1 plus cotangent squared of phi plus r squared theta dot squared minus, the height is r cotangent phi. So we have minus u, so we have minus m g r cotangent of phi. And so dl by d theta is 0, there's no theta there, and dl by d theta dot is, theta dot is here, so it's just m r squared theta dot, and that's just the momentum in the z direction. Sorry, it's the momentum, that's the constant angular momentum in z direction. So that's a constant. dl, then we can do dl by dr minus d by dt of dl by dr dot. Right, so we have r dot is just this, and this becomes, and then we take another derivative of that, so we get And then we can divide out the mass. Right? We can see that they're all proportional to the mass. So we'll get r double dot, we'll get the acceleration in the radial coordinate minus r theta dot squared sine squared of phi plus g sine phi cosine of phi, and this is equal to 0. And that's the equation of motion.